Okay, so we are going to be working on 9C, which is differentiation with a polynomial with a negative integer. So this is identical to what we've already done in terms of our positive integers. So let's look at this, which is we've got f of x is equal to x to the power of n. And all that happens is our n goes out the front and it becomes nx. And we are taking one of our powers away. So if what we can see here is if I've got f of x is equal to x to the power of -1, this -1 is being taken out the front and times in with the coefficient, and I'm taking one away from my power, so -1 take away 1 becomes -2, which is what I've got here. Same thing applies if I've got f of x is equal to x to the power of -2, that -2 goes out the front, and I take one away from my power to get -3. Let's look at the proof using first principles. So I'm just going to plug in x plus h into this equation, and then I'll be taking away that function. So with this, to make it easier, I'm just going to get it to be a positive power. So it will be 1 over x plus h and 1 over x squared. Now, from this point, I need to make it a bit easier on myself because it looks a bit confusing at the moment with this divide by h sign. So I'm going to change it. Divide by h is the same as timesing by 1 over h. Now, from this, we are then able to make the denominators the same by timesing each side by the respective denominator. So I've times the left-hand side by x squared, and I've times the right-hand side by x squared plus h. Now, this next step, I'm going to do multiple things at the same time. I'm going to put my denominators together and expand. So remember, x plus h squared is a perfect square, and then all the terms in there are all times by x squared. Likewise, I'm going to apply the difference of two squares on my numerator. So that will be x plus h and x take away in brackets x plus h. So that takeaway sign applied to both the x and the h. So now from this, now we've done this. Next step that I'm going to do is look at simplifying it slightly further. So I'm just going to get my pen, and straight away I've got x take away x. That cancels out. And x plus x is 2x here. The next step is I'm going to get rid of this h here and cancel out this h here. Because I've cancelled that h out, it means that I can use my limit now. Anytime I see a h, I'll make a 0. So that will be 0, this will be 0, and that will be 0. And that leaves me with negative 2x over x to the power of 4. Now, from this point, I can cancel one of the x's away, and that will be negative 2 over x to the power of 3. I can apply the limit, but I don't need to because I've got no h at the moment. Let's look at this next one. 1 over x plus 4 is equal to x plus 4 to the power of -1. So the first thing I'm going to look for here is I would like to, again, do the first principle. So that's the first thing I write down is my equation. From this equation, I substitute x plus h into my function, and then I rewrite my function that I'm taking away. Now, from this point here, we need to make it a bit easier by getting one fraction. So that means I'm going to times both sides by x plus 4 and times both the other side by x plus h plus 4 to make my denominators equal. Here, I can then simplify this a bit further. So I'm just going to cancel a few things out. So I've got x and I'm taking away x. I've got 4 and I'm taking away 4 because this takeaway sign applies to everything here. So that leaves me with just negative h on top. Now, so the next step is getting rid of that h. So if I'm dividing by h, that's the same thing as me timesing by 1 over h. So I can cancel that h and cancel that h, and that leaves me with negative 1 on top. Now I can apply my h as h gets closer to 0, so I can make h 0, and I'm left with x plus 4, x plus 4. That gives me negative 1 over x plus 4 squared. So let's have a go at differentiating with respect to f of x is equal to 7x to the power of negative 3 plus 4x to the power of negative 1, take away 5. So the first thing here is I'm going to apply this power and take it to my numerator, and I will subtract 1. This negative 1 will apply to my numerator, sorry, to my coefficient, sorry, and I will subtract 1. So that gives me negative 3 times 7, and x to the power of negative 3 take away 1. And then I've got negative 1 times 4 is negative 4, x to the power of negative 1 take away 1, and I simplify it. Again, with this question here, we've got 6 over x squared, take away 10 over x cubed plus 8. So the first thing I want us to do here is I want to get our x's to be in our numerator. So to do that, I've got x squared. I'm going to turn that into x to the power of negative 2 and x to the power of negative 3. I then apply my power to my coefficient. So this goes over here, and I take 1 away. My negative 3 goes out the front and times, and I take 1 away, and of course a constant is just cancelled. All I do now is just simplify, and I get negative 12x to the power of negative 3 plus 30x to the power of negative 4. So if we are doing this question here, and we've got x squared on the bottom, so we really want to get rid of that. So to do that, we are just going to get it to the top, but that also means the whole top is going to be times by x to the power of negative 2. So we need to expand. So if I times this, 4x squared times x to the power of negative 2 means it's just 4. 6x times x to the power of negative 2 just means it's 6x to the power of negative 1. 1 plus negative 2. And then we've got 9x to the power of negative 2. Now we've done this, we're just applying our rule. The 4 is a constant, so we don't care about it. It just cancels out. The negative 1 here goes out the front, and we take 1 away. The negative 2 goes out the front, and we take 1 away. So it's the same rule that we're applying every single time. Now we just simplify that. Okay, let's look at finding the gradient of a tangent line to the curve at the given point. We've got y is equal to x to the power of negative 1 plus 2x squared, where x does not equal 0 at 1 and 3. So first to find the gradient, the first thing that we are going to do is we are going to find the derivative. That means we're going to grab the negative 1 and take it out the front, and we're going to take 1 away from the power. We're going to keep doing that. From the 2, we go out the front, and we take 1 away from the power. So that gives me negative x to the power of negative 2 plus 4x. From here, I grab my x value, which I know is 1, and I plug that in to find my gradient. That gives me 1 plus 4, which equals 3. So the gradient at 1 and at 3 is going to be 3. The gradient of the curve y equals a over x plus bx squared at the point 2, 5 is 3. Find the values of a and b. So this is where we need to create two equations, and we'll use simultaneous to solve it. So the first step that we need to do is write down our equation that we have. I'm going to first focus on the gradient. So I'm going to find the derivative, but to do that, I need to get my x to be on top, so it'll be x to the power of -1. If I'm finding the derivative, I take -1 out the front and I take 1 away. I take the 2 out the front and I take 1 away. So that means I'll have -ax to the power of -2 and 2bx, because 2 take away 1 is 1. That's my first equation. From here, I'm going to get my second equation. So first thing I'm going to do is start off with my original equation, and then I'm going to substitute 2 in. So this is my first equation, and 3. That will leave me with just a and b. So I've got x is 2 and gradient is 3. I simplify this. 2 to the power of -2 is a quarter, and 2 times 2 is 4. My second equation I'm going to do links back to my original equation of y equals a over x plus bx squared. So if I have this equation and I know the x and y, the a and b for both of these equations must be the same. So I grab my equation and plug in those two values and I simplify it down. Now, I can see that they both have 4b, so I'm going to use the elimination method here. So the elimination method means because they both have 4b, I can just take each equation away. So 4b take away 4b is 0, 5 take away 3 is 2, and a half a take away -1/4 is 3/4 a. From here, I divide by 3 over 4, and I get a is 8 over 3. I plug that into one of my equations and I solve for b. So that is half times 8 over 3, which gives me 8 over 6. I can simplify 8 over 6 down to 4 over 3. And then I take 4 over 3 away. We know 5 is the same as 15 over 3. So 15 take away 4 is 11. So 11 over 3 is equal to 4b. I divide it by 4 and I get 11 over 12.